Have you ever wondered why your coffee cools down to room temperature if left untouched? Or why, no matter how hard you juggle, you can't keep more than a few balls in the air without dropping one? These everyday phenomena and many others are governed by a fundamental principle in physics known as conservation laws. In the simplest terms, conservation laws are the rules of the universe that dictate that certain physical properties or quantities do not change over time within an isolated system. These laws are like the universe's bookkeeping system, ensuring that everything balances out in the end. Let's dive into the world of classical physics. Here, conservation laws govern energy, momentum, angular momentum, mass, and electric charge. But what does that mean? It means that in any isolated system, the total amount of these quantities remains constant. They can change form, they can move around, but their total amount never changes. Consider, for example, the law of conservation of energy. This law tells us that energy cannot be created or destroyed. You can transform it from one form to another, like when you burn wood to create heat, but the total amount of energy in the system stays the same. Imagine a pendulum swinging back and forth. At the highest point of its swing, the pendulum has maximum potential energy and minimum kinetic energy. As it begins to swing down, the potential energy is converted into kinetic energy. At the bottom of the swing, the pendulum has maximum kinetic energy and minimum potential energy. But if you add up the kinetic and potential energy at any point in the swing, the total energy remains constant. The same principle applies to the law of conservation of momentum. If you've ever played pool, you've seen this law in action. When the cue ball strikes another ball, it transfers its momentum to that ball, which then moves while the cue ball slows down. The total momentum of the balls before and after the collision remains the same. Now let's talk about particle physics. In this realm, other conservation laws apply to properties of subatomic particles that remain unaltered during interactions. These laws help scientists predict the behavior of these tiny particles and understand the fundamental building blocks of our universe. In conclusion, conservation laws are the universe's way of maintaining balance. They ensure that in an isolated system, certain physical properties remain constant. These laws govern everything from the swinging of a pendulum to the behavior of subatomic particles. They help us understand and predict the world around us, from the smallest particles to the largest galaxies. So the next time you see your coffee cool down or you drop a ball while juggling, remember, it's all a part of the universe's grand scheme of balance and conservation.